Hello everyone and welcome to another episode of Darko's Gamedev Cookbook. Today the subject I'm bringing to the table is super interesting. Today we're gonna be building some clouds. That's right, the things you see on your screen right now, and I'm gonna show you the simplest technique you can use to make your own clouds in the safety of your own home. Stay tuned. The thing you see on your screens right now is the thing I made in 10ish minutes, and it entails using a technique called value noise. When talking about noise in general, when you're dealing with shaders, when you're dealing with certain things in game that require some sort of a pattern, you will deal with random numbers. And sometimes you want to deal with numbers that are not really super random, or you want to deal with numbers that are random but also have some sort of ups and downs that are granular. So you want to have some sort of a texture that is not zeros and ones, and it doesn't look like the classic static noise you see in your old analog TVs. You want to see something that looks granular and it looks soft. And that's one of the techniques that we need today, because we want to make clouds that don't look like just a bunch of static noise. We want to make something that has some sort of granularity and softness and fuzziness to it. So for that, let's head into the code directly, and I'm going to show you how it's done. The first thing we gotta do when we do this thing, we need to generate that static noise I've talked about earlier, because we're gonna use that static noise as our template to actually generate that granular or generate that soft noise I just talked about a second ago. So we're gonna make a function that returns a float of some kind. We're gonna name it noise. And that noise is gonna generate noise based on a vector2 argument. That's gonna be something like vec2pq. Okay, now we get to the first subject that is quite interesting. What is a random number? A random number is never really random, because nothing is really random. Everything is based on something and produces a result that might resemble something that looks random because we don't recognize a pattern. And that is exactly what we need to do here. We need to create something that doesn't have a pattern that is visible to the human eye. And guess what? We are super easy to deceive. So you can create these kinds of patterns just by following certain math principles. There, of course, is a pattern, and there always is something like that, but it's almost impossible for you to see it. You'll also see, like, when we generate this noise, you can make it so bad in terms of randomness that you can't see anything, any pattern. It looks super scrambled, but you can also make it just by changing one number. You can make it super patterny, and you'll start seeing patterns in just a second. So let's head off and do some math magic to actually get this thing running. So for a start, let's just return a sinus of pqx plus pqy. Simple as that. Here for our color, I'm just gonna twist it a bit and say, well, this is vector3 noise uv. Just simple and stupid like this. And we get this. Of course, sinus, it's a periodical function. Of course, it's gonna look something like this. It depends on x and y, so you get the diagonal shape. Everyone who knows who knows math will kind of expect this. If you didn't expect this, again, just bear with me. We're gonna do something cool in just a second. If we do something like, well, this is not gonna help, obviously, because the sinus function is gonna return between -1 and 1. But if you multiply this like this and do fract, you're gonna start seeing some weird things. Also, if you multiply this by something and this by something, oh, there you go. We have something. Right? That was quite simple. And of course you can see this blinking happening because of the fragments and our resolutions and the stream resolution not really matching. So I'm gonna pause it just so you don't get fuzzy there. But this is already looking quite random, actually. So we hit the quite a good spot just accidentally when starting it. So if you look at this thing over here, this is just called noise. So if anyone mentions noise in the Gamedev world, this is how it could look like. It could also have a color assigned. In this case, all of our 3 color axes are one or are the same number, so it's going to result in grayscale random number. But you can make 3 random noise functions that behave slightly differently and work with different numbers, and then you get a color palette of RGB noise. We don't need RGB noise for our scenario. So this looks good. I'm not going to touch it for now. We might come back later on to see if we need to change something. But let me see if I do this. Yeah, we don't need the fractal component here. So we leave it like this. We have our noise. That was fast. And also, like, if you want to make noise, you can also feel like a kid in a sandbox, basically, just playing. Like, go crazy, make your own functions, and you can get even weirder things. But this is perfect noise. Like, you can't see, maybe some of you can see some patterns, but it's not that important. For the case of clouds, we want to make or use this texture that we have right now and make something that's granular, that looks softer, and it doesn't have these jumps from pixel to pixel. It needs to go like this. So we're gonna do something called, or create a function called noise smooth. And then we're gonna say, yeah, this one is also gonna accept vector 2, PQ, why not? Just to kind of differentiate between the input UV and something else. Name it whatever you want. It's not really important. So noise smooth, we gotta do something different here. The first thing we gotta do for this smooth noise, we're gonna separate our canvas, the whole thing. We're gonna separate them, it into a bunch of squares, and then each square will have a single color. And then we're gonna go pixel by pixel, get all the squares around that pixel, so 4 blocks, and then get the color of each of those blocks, and then interpolate between those color to get the color. Oh, this pixel is of this color, and that's what we're gonna do in just a second. The first thing we're gonna do here is gonna say that this is in some sort of an index we're gonna have that's gonna go from 0 to a certain number. And we can say floor PQ, and we're gonna return let's say noise index like this, and here, yeah, that should do it actually. So here, instead of this noise, we can already transfer to noise smooth. And now we don't get anything. Let me see. PQ. Yeah, exactly. So right now our UV is going from 0 to 1. We want to make it go from 0 to a certain number. So maybe, I don't know, we can do 10. When you do 10, you get a grid of different cells with different colors. You'll also notice that instead of having squares, we have rectangles. And guess what? They are exactly the same size as your aspect ratio in this case. So we need to fix the aspect ratio. So I'm gonna say that my x is let me see, resolution. Yeah, so we multiply it with the aspect ratio, we get the right x and y now. So we have squares instead. Perfect, we want to do that. And then we go here and we say, cool, index. What is going to be index in this case? So if you go a box through box, you need to know that this is index x0, y0, x1, y0, x2, y0, and etc. And in the opposite direction, y increases, and like the basic stuff. So this index is what we're going to use as a base for getting colors of each block. So if we want to know in our new noise texture what sort of a color our pixel will have, let's say this pixel over here, we're gonna take this box, this box, this box, and this one over here, 4 of them, get the color, get the mixture of these color depending on where this pixel is. Pretty much, that's like the gist of it. So it's gonna get the color of this square the most because it's the closest to it, or it is kind of a part of that. But it will also perform sigmoid interpolation that you're just going to see in a moment what we're going to do to kind of get this smoothness. So we're going to do this. We need to calculate the value of the top left square, top right, bottom left, and bottom right first. And then we're going to mix them. So what we're gonna do here is we're gonna say top left equals noise index float top right equals noise index. And now we're gonna move one square to the right. So we're gonna do vec2 0 1 0. And then we're gonna calculate bottom left equals noise index vec2. So we're gonna go down. And then we're gonna do bottom right like this. And then we want to get the color of mixture of the top part, mixture of the bottom right part, and then like mix all of that together. That should be working. So we have top equals mix top left, top right, and then something, right? We have no idea what that will be. We need to have some sort of a distance in the x-axis, and then we have bottom. Something, and then we're gonna need to have the return. We're gonna need to return the mixture of final colors. So we're gonna do like this. Cool. What is gonna be this one? Well, we need to get the distance on this and this axis within the square, and since this will go. The square itself, the number will go from 0 to 1, 0 to 1, 0 to 1. Within that index, we can just take the fractal part, the fragment part of the PQ part, because it's gonna go 0, 0.5, 0.6, 2, 2.2, 2.5, and so on. So we're gonna take the point part. We're gonna say vec2. I don't know. Like this. Ignore the naming. You can name it whatever you want, as long as you know what that should mean. So we're just gonna go frag x, frag y, and then not y. This is also left and right side that we're interpolating between, and then you have the top, you have the bottom, and now you need to figure out what this ratio is going to be. So you say y. So you get something cool, right? It looks kind of neat, but it is kind of obvious that we are doing a boxy approach to this. So instead of going this, just blindly going and getting the fract part of your number, we need to do a so-called sigmoid interpolation, or any kind of interpolation that is smooth, that you think is okay to use. We have a built-in smooth step function in GLSL that we can use, that we will use now. So if you do frag between the full spectrum of the value, you can play with these values, but you will get nothing you want to. Trust me, at least not in this scenario. If you do this, then you get something that you might already recognize. And it looks quite similar to Berlin noise. It is not the same approach. This is basic value noise, but it is kind of going along the same lines in terms of logic, but it's not manifesting in the same way for sure. This part that I'm changing now, you'll notice that I'm basically zooming in and out in some way. Usually when you have this kind of a noise, you don't apply only one layer of the noise. Like, you want to get this texture that looks diverse. You want to have a set of noise layers that go in octaves, and I'm gonna show you in a second what that means. So you have the basic layer, then you have another layer, and for this layer you use the 2 to the power of x, use 2 to the power of x as your UV multiplier, and then you also multiply that color with some sort of a strength or alpha. So you put 8 here, 2 to the power of 3, And then when you do that, you also need to multiply the end result and the end color. You need to soften it a bit, so this layer affects the end product 2 times less in a sense. If you do this, you get to this. Then we can, this is 1 octave, or it's one part of the octave. We're not gonna save it now. We go here and we say 60, and we say, we do this. Now it's kind of looking similar to what you might have seen in different examples online. And this one goes like this. I mean, you can do as many as you want and also tweak them. This is not something that you must do. You can do it. You can do it however you want to and whatever pleases your eye. In the end of the day, so that's what's important. If I do this, guess what? We get something that looks like noise, and it also looks like smoke slash fog slash clouds, like exactly what we want to get. So we're gonna do this. And then we're gonna say that a UVX plus equals I time. I time, as I said in one of the previous tutorials, is just the a floating point number indicating time. So you can use that to move stuff around the scene if you want to. We're not playing right now because it was flickering, but now it's not gonna be flickering, so we can use this. And now we're gonna start introducing some other things that might start resembling your sky. So the sky itself, we want to have some color to that sky, so I'm going to do this. Equals vector 3, 0.5, that's the red component, 0.7. Now I'm just guessing. That's going to be sky, and here we're going to do some sort of mixing. We're gonna fix this in just a moment. So the color, or whatever the value we get here, it is not the color I would intend to put as the final color of the cloud. It's more of a filter out value that we're gonna be using to kind of crop different parts of this cloud out, or kind of filter it in the final composition. And you're gonna see in a second what that would mean. But here when we're mixing, we're gonna be mixing cloud color. That's not gonna be the col, it's gonna be some color. I'm gonna put it to pure white. Then we're gonna say that we're mixing it with the sky, and we can say maybe 0.5, and we're gonna get something that doesn't have any sense at this point, because we're just mixing the sky color with white at this point. However, if you put color, you start getting something. You can also put 1 minus color, and you get the inverted situation of the whole noise, and that doesn't break any value, but it's quite interesting anyway. I also want sky to kind of have some sort of a gradient. I want to be lighter on the bottom and darker on the top. That looked neat, so I think we should do that. So if you do 1 minus UV Y, it will look like something like this, and then maybe multiply it by 2. That is definitely too much. Maybe multiply 112. Actually, what we can do maybe not 1, but like this, and then we can drop this part entirely and see how we stand. Maybe move it like this. So you can tweak these numbers to your liking. I don't know, maybe softening it up a bit might be better. Something like this, I don't know. Okay, so we have some sky, we have some clouds. One more thing I want to do, or there's more things, but one more thing we can do. We can say that the color, now we're gonna do the filtering out part, kind of. So we're gonna take a certain range of colors where we're gonna interpolate, and then everything below that will be 0, everything above that will be 1. Basically, it's the same thing that we did here, but we're gonna need to do it on the clouds now, because I think it looks nicer and also gives you more control over what you're looking at. So we're gonna go between 0.2, 0.9, and then we can take this one. Let's see if this changes anything. It does. So we can maybe, if you do this, yes, that definitely doesn't help, but we can do this. Interesting. So you can see what sorts of things you can do here. And that's why I want this smooth step to be here, because it gives you some sort of granularity over and control over how much your clouds are there. And yeah, basically you can do whatever you want. You can also do things like this here, whatever you like. And now I want to, as like a final note to make it look like something that's actually alive. We're gonna do some parallax movement. So we can do uv2 equals uv, vector 3 uv3 equals uv, and then here uv2 is gonna be, since I will want to move upwards, maybe I time divided by 50. I don't know, we can treat this. uv3 minus equals I time divided by 40. And of course, yeah, this is not vector 3, this is vector 2. And here I'm not using a float number, so we can do this. And then here, instead of using UV for different components, I can use maybe something like this. So it gets a bit more alive. You can get different types of shaders. You can get cartoony if you want. You can get something like this. You can start inverting it and doing all sorts of weird things if you want to. There's really many things you can do. And I think I will just maybe tweak a bit the values and then get back with the final version of the shader. So I've been tweaking some values, and I think I found the best thing we can use in our example. So these have 50, 40. We're gonna be moving this one here because I forgot to put new UV calculation above where we're actually starting these, because the movement will be a bit weird without that. Then also the thing we can do, we can invert the color over here. When we invert it, we get really interesting results, and then you can also play with this number and put it to something above 1. So the color itself will always be, of course, clamped to 1. However, the value we have at this point goes above 1, because even when you divide the octave result, the noise you get here, it might be above 1. So this will affect the final calculation of the color, because the interpolation will go above 1 itself. So if you put this to 3.9, you will start losing clouds, because obviously now in this scenario your interpolation is super, since it started smooth, it's going to be super low at the point of 1. So you can play with these numbers and do really all sorts of crazy things to actually make something you like. And also the sky might be a bit too dark. After playing with it for a while, I think this was one of the terms. Of course, you can get it with different kinds of combinations of expressions over here, but I was just playing with the numbers, and this is what I got. So you can use this if you want to. If you like maybe darker or brighter sky, feel free to play with this. I think this is a really nice playground in general. For you. And also I want to add one more interesting thing that I really like, and that's this interactivity that we can add with the mouse movement. So we can say that our UV is gonna be affected by iMouse, which is gonna be the position of your mouse within this canvas over here on the left side. So as usual, this will be 0, 1, 0, 1, So we want to maybe divide it by a certain number so it doesn't affect us too much. And iMouse also has X and Y coordinates, so we're going to do this. So now when we compile that, when you do this, you actually can move across your sky. Now you have your own personal sky, your own personal clouds that you can model however you want. And the fun part about this is that you can like tweak this indefinitely. You can do any sorts of clouds you want with any sort of density. You can also make them, if you want to be crazy, you can make them go move in some way or change their density, maybe something like this by time, and make them pop maybe slower. Now of course the sinus function is doing its own thing, but you can see what sorts of things you can do. You can create them, move different layers in different kinds, generate different kinds of noises and so on. I really hope you liked today's tutorial. That's pretty much everything I had for you today. It was short and sweet, and I think this is the format I might be doing more in the future. Until the next time, I guess, stay safe and see you.